It really is difficult. First, starting off with landing on Mars. Just getting to the surface is difficult. Once you're on the surface safely, you've got to have something which will survive the extreme temperatures at night. That's why we do all the testing in the thermal chambers and so on, to be able to test for that. But once we have the rover on there, this will be a bit like a roving geologist, able to go around, look at places, decide the next target for the next day, and then drill underneath the surface. And that's the key new thing for the ExoMars rover, to be able to do that.
These rovers you see in the background here are effectively research and development platforms. They have some of the sensors we would expect to see on the real vehicle, and they allow us to test out some of the software that we have that is effectively implementing some of these autonomous systems ideas that we've got. And it allows us to test them out in the first instance in this quarry environment, which is kind of preparatory work for a later mission to somewhere which is more geologically representative, like the Atacama Desert in Chile, for example. Because Mars is so far away and we can't talk to the rover directly, it's a bit like we have to prepare instructions in advance based on a small amount of information. So it's almost like the rover sends us a little postcard, the guys try and work something out, they send some information back, it moves a little and it sends back another postcard. That's a traditional way of doing things, which is quite slow, but the rover, of course, has access to all the information right in front of it because it's there. So what it can do is effectively say, okay, you've asked me to go from A to B. I can build maps in 3D of the world around me. I can also work out where I am with respect to those maps. So even though you've told me to go from A to B in a straight line, I might see there's a big rock in the way. It can work out how to navigate around that rock and make sure that it reaches that target, because it has access to information that the guys on the ground don't have necessarily when they're doing the planning. Mars does present some unique challenges, so usually what comes out of these kind of experiments is a really interesting fusion of ideas. So we have some technologies that were originally planned for applications on Earth. We have a unique set of problems on Mars, and we end up with a new technology usually which has reached beyond Mars itself and can be commercially exploited. So it's very much a circular kind of dependency. For example, you may want vehicles in remote parts of the world to do exploration, and you want to minimize the amount of energy use. You may have a remote platform which is surveying a distant oil pipeline in the desert. The vehicle, using the kind of technologies we've developed here, could indeed do the same kind of thing in those remote regions. It could also look out for targets on the side of those oil pipelines, maybe cracks, for example. We do similar sort of things in another way on Mars, where we're looking for targets of interest from a geology point of view. So there's these really interesting different types of applications which, in an abstract sense, are effectively the same thing.